Managing wireless connectivity issues. Now more than ever before, wireless communications are a de facto standard for many businesses. On one hand, many companies use wireless to provide outside folks, contractors, guests, visitors, and so on, access to the internet, but even more commonly, as you know if you've used wireless connections, wireless opens up entire new vistas in mobility and portability with computing. Of course, wireless in a business environment brings with it support issues, which is where we come in as desktop support technicians and what we're doing in this nugget. We're going to start by looking at client-side wireless configuration in Windows 7. If you have experience setting up wireless client connections in Windows Vista, you certainly have a leg up. Those of you who are migrating directly from Windows XP to Windows 7 are in for a little bit of a learning curve. We're going to discuss all the major terminologies associated with 802.11 communications, paying particular attention to data encryption. Again, this whole frame is a business wireless local area network, or WLAN, so data encryption becomes even more paramount than usual. We'll look at the wireless profile feature in Windows 7, and then finally we'll review group policy settings in Windows Server 2008 R2 to make managing wireless across your entire network a lot easier to do. Let's get started. What is involved in setting up a Windows 7 client computer? In most cases, a portable or notebook or laptop computer, depending upon how you call it, to a wireless local area network, or WLAN. What do you need? What information is required to get that connection going? Well, first we have what's called the Service Set Identifier, or SSID. This is nothing more than the logical name for the WLAN to which you're trying to connect that user. Now, it used to be believed, a little bit too widely in my opinion, that a really good security strategy is to suppress SSID broadcast. Now, there's two schools of thought. One is a malicious user is going to be using wireless sniffing tools where they can see SSIDs, whether they're being broadcast or not, so there's that. And then there's also the fact that in a business environment, it's just frankly a heck of a lot easier when you're broadcasting the SSID to help your users connect to the appropriate WLAN. For instance, you might have a WLAN segment for employees, another one for managers, and a third one for guests. Another consideration, and this is more of an architectural question, is which variety of the IEEE 802.11 protocol are you using? B and G offer vastly different speeds, 11 megabits per second and 54 respectively. Now in 2010, I would be really surprised if you were supporting B in your network. This is definitely considered a legacy protocol by this point. G is the de facto standard. What's cool about B and G is that they're compatible with each other. They both operate on the same frequency, and so some networks will do B/G, such that clients are connecting G, but then if you have an old computer show up with a really antiquated wireless card, that person can access using the older B protocol. The latest and greatest flavor of the 802.11 specification is 802.11n. This offers much faster speeds in the vicinity of 600 megs with a much wider range also than G or B. However, adoption of N is still not considered widespread at this point. So we have the SSID. We're connecting using some implementation of 802.11 protocols. What else do we need for client-side wireless config? Well, certainly there's the issue of security or encryption. And here we're thinking of encryption of two streams. We're thinking of the authentication protocol that's being used and how we're handling sensitive information like logon credentials, username, password, and then even before that, how we're handling connection from the client computer to the access point, the wireless access point. The second stream deals with once that connection has been made and authentication has been done, how are we protecting the rest of the data stream? As that corporate user is passing packets around through the network, the path is going to go from the user's computer over the air to their nearest associated access point. Access points are always hardwired into a switch, and then we hit the wired backbone of your network infrastructure. However, encryption is crucial at this point in the air so that a malicious user with a big ol' antenna and a Linux box that's capturing packets coming off the air is not able to decode and view the payload of those frames. The three security protocols or encryption protocols you need to be aware of are wired equivalent privacy and Wi-Fi protected access. Now, WEP you should not be using under any circumstances. WEP has some fundamental design flaws that make it now in 2010 trivially easy to crack. WEP uses just a static 128-bit key for security or for authentication. And like I said, any mid-level, even late beginning stage hacker will be able to crack your WEP key in just a matter of minutes to hours, depending. Therefore, when it comes to encryption protocols, you should be looking at Wi-Fi protected access. At that, there's two versions, WPA1 and WPA2. Now, for the purposes of the 685 exam, we just need to focus on the major differences between WEP and WPA. Just know that WEP uses a static key. It's not very scalable because of that. You have to hard code the key on every client device that's going to associate in your WLAN, and it's fundamentally flawed. WPA comes in the two versions. 2 has some significant advantages over WPA1. In my experience, I've only used WPA1 on WLANs that had legacy devices that were not able to support WPA2, but as long as your wireless access points in your Windows 7 boxes support WPA2, definitely choose that. WPA2 also gives us support for this really excellent IEEE 802.1x authentication protocol. 802.1x gives you a much tighter control as a network administrator over how authentication happens. Besides having two versions, we also have two implementations of WPA. They commonly show up in Windows 7 as WPA Personal and WPA Enterprise. The Personal is fine for home networks and even for, say, small office, home office environments, but if you plan a mid to large size rollout of a WLAN, you absolutely want to look at WPA2 Enterprise, which is very different in its implementation compared to Personal. Personal uses what's called a pre-shared key, or PSK, such that, again, you have to enter that value. Hopefully you've got a really long, really complex passphrase on every client device, and also store that information on your access points. That makes management, well, to say the least, problematic if, for instance, you then want to change the pre-shared key value. You're going to have to manually update all your client devices. AES is a specific encryption protocol that can be used with WPA, as is TKIP. Your decision to go with one or the other of these specific encryption protocols that support these authentication protocols is going to be that counterbalance again, this time between speed or network performance on one hand and higher security on the other. Some encryption protocols are just faster than others. Now, to finish our discussion, WPA Personal is fine. It does the pre-shared key for small networks. It's all right. WPA2 Enterprise is a scalable method for handling wireless authentication and encryption. If you're going to use WPA2 Enterprise, you're going to need a Radius server to handle or forward and process those authentication requests. Cisco makes Radius software. You can purchase wireless access control hardware devices that include Radius, and the path would be, for instance, the client computer comes up, the wireless card starts broadcasting and wants to attach to an access point. The user attempts to log on to the domain. Before anything happens, before that user can hit Google or their local mail server or any domain resources, the access point forwards the user credentials securely to your Radius server, and if you're not using another directory service like Active Directory Domain Services, most Radius server implementations can perform the authentication there. Typically, though, for our purposes in 685, we're dealing in an Active Directory Domain Services environment. In this case, your computer that's configured or device that's configured to do Radius will forward the authentication credentials to a domain controller. Authentication will take place, and then the channel's reversed and the user's allowed access to the network. Setting up WPA2 Enterprise with Radius also in almost all cases involves PKI or public key infrastructures as well, where you're handing out computer and or user digital certificates. Long story short, there's a lot more to setting up an enterprise WPA infrastructure, but the good thing is once it is set up, you're offering your users and your constituents within your WLAN a high degree of security as well as scalability and performance. For the next couple of whiteboard slides, I'm going to give you a screenshot-based walkthrough of client configuration of 802.11 networking in Windows 7. So we'll start with this upper left picture that shows what happens if you click the wireless networking icon that appears in the notification area by default when A, the machine does have a working network card, wireless network card, and B, that card is configured for auto discovery. Now, that auto discovery feature, you might recall from earlier in this Nugget series, is going to depend upon the network location that you've attached to that wireless network. Now, as soon as the wireless interface comes up for the first time, if you're in a domain environment, you know by now that the wireless connection will automatically be routed to the domain Windows Firewall profile. If you're in a public area like a Starbucks or an airport, you'll be asked to associate either public or home as your location. Now, the home and the domain allow a degree of flexibility here in terms of what you see. If you choose public, then your broadcasting is going to be severely limited. In this case, you see in the screenshot that I'm currently connected to a home assigned WLAN, and because of that, we can also broadcast and see other WLANs that are within range of this particular computer. Now, I want to give a heads up to a really excellent tool that we've talked about a little bit earlier in this training called Network Shell or NetSH. You can use NetSH in the WLAN context to view a list of this same information, all other WLANs in range. What you would do is open an elevated command prompt, NetSH WLAN, show networks, interface equals, and then you would pass in as a quoted string the logical name of your wireless interface. So in this case, mine has the default name wireless network connection. So I would type show networks interface equals wireless network connection, and I'll see a much more verbose list of networks that are within range. Another really great troubleshooting aspect of using this NetSH command is that it will not only show you the signal strength and name and encryption type used by each detected WLAN, but it'll also give you the channel. That can be especially helpful if you're going to bring up a WLAN. You want to put that new WLAN on a channel that's not already being overused. That'll increase signal strength and performance. Now then, you see that if you are able to detect other WLANs, the graphical interface from the notification area shows where you're connected and the relative signal strengths. If you click another entry in the list, depending upon whether it's open, you'll notice this little exclamation mark lets us know that there's actually no authentication protocol set up for this network, which is obviously a security risk. The other ones do have some kind of protection on them. So that's that. You can also open the Network Sharing Center directly from this notification area icon, which now we'll move to the lower right of this whiteboard. We see a fairly blurry, unfortunately, I'm sorry about that, picture of the Network Sharing Center, and a lot of this we've seen before, the network map, the active networks and their locations. I want to draw your attention to the task area. This option here, manage wireless networks and change adapter settings. If you go into change adapter settings, you'll come up into network connections here, where again, you've probably been here, done this, bought the t-shirt. You see all interfaces on the machine, including, as you see here, my wireless network connection. If you right click that icon, you'll notice you can enable or disable. That's another good troubleshooting tip. Maybe the person doesn't have any wireless connectivity because for some reason their wireless interface is disabled. Yet another helpful troubleshooting tip along those lines, many laptops have a hard switch that turns the wireless card on or off. I've spent way too much time troubleshooting the software aspect of wireless communications only to realize that I'm never getting out of the gate because I overlooked the hard switch that was in the off position. Moving on, this whiteboard slide is basically an entree or an introduction to the notion of the wireless connection profile. Essentially, when you store credentials, SSID name, passphrase, encryption type under Windows 7, you create a persistent network profile such that whenever that Windows 7 machine redetects that WLAN, it will automatically invoke the appropriate profile. Now, you can invoke a connection to a wireless network manually from the Network and Sharing Center. You just choose Set Up a Connection, and that opens up the dialog you see in the upper left here, and you can choose Manually Connect to a wireless network to create a profile manually. And to do that manual client-side connectivity, we simply would enter, it says network name, but we know that that's the service set ID or SSID. We'd have to know the security type, WPA2 personal, WPA2 enterprise, etc. We'd have to know the encryption protocol, and then we can type the security key, optionally keeping that in clear text while we're on this box, because some of these passphrases, at least the higher security ones, are very difficult to know if you've typed them correctly until you hit next and get a failure, so it's nice to be able to see that data in plain text. We also have the ability to auto start the connection whenever, as I said, your computer or your user's computer is within range of the WLAN, and then connect even if the network is not broadcasting. That's going to be important if you're not broadcasting the SSID. Finally, we have this whiteboard slide that in the upper left shows what happens if we're in the Network and Sharing Center and we choose the Manage Wireless Networks option. By the way, all of these dialogues you're seeing, you should know by now that another way to directly invoke these is to simply open the Start button, place your cursor in the search box, and type some of that text. In this case, I humbly submit that if you type Manage Wireless Networks in the Windows 7 search box, the very first search return you'll see in the Start menu is a link that takes you to this dialog. Now, this dialog is different from the one we saw a moment ago. Let me jump back there for a moment. Here we go. The Network Connections dialog. Network Connections, of course, is going to give us access to, say, the TCP/IP properties, the enable/disable functionality, basically your system's administration options. That's under Network Connections. By contrast, when we come into Manage Wireless Networks, you're seeing a list of any network profiles that have been loaded and stored on that Windows 7 client computer. And if we go across the top here, you can add in a new profile with the Add button. You can remove a profile. For instance, if you created a profile on a client site and then you're finished with that job and you no longer need to store that information, you can actually come back to the previous dialog and look at the properties of your adapter. You can set profile preferences and quick link back to Network and Sharing Center. Now here you see my WLAN listed, and if we right click, we can look at the properties, we can remove the network, or we can give it a logical name different from what it comes in as is the default, and the default is going to be the SSID. If you look at the properties of your connection, you wind up with a dialog that should look very similar to a wired Ethernet connection in terms of your components, your Microsoft Network client, optionally file and printer sharing, and your IPv4 and or IPv6 options. Now then, let's turn our attention again to troubleshooting wireless. This whiteboard slide is devoted to troubleshooting signal strength. As you saw in the previous walkthrough I just completed with you, you can graphically see in kind of a triangular shaped motif the relative signal strength you're getting on that Windows 7 computer. The idea is the more bars you have, the stronger the signal. And what are some factors coming in from a desktop support technician's point of view? What are the factors that go into having a stronger or weaker relative signal strength? One of those is, where are your access points? There's a lot to deploying a WLAN. There really is. There's the physical infrastructure aspect, of which position is key. There's the logical infrastructure option, how we're handling encryption, how we're handling authentication. There's the management aspect in terms of configuring client connection profiles and all of this. Getting back to the first, the physical setup, the position of the AP is crucial for many reasons. There's the logical or obvious thought we want to have as many APs as possible in order to spread that signal and not have any dead spots on our campus. We ideally want to see enough overlap in between each wireless access point such that there's not going to be any dead areas where somebody could potentially not get a signal. So location is critical, but also we have to think, what is the physical environment of that location? You might think, oh, well, a WAP or a wireless access point, sometimes called a WAP, would be great up here above the drop ceiling in the plenum. Well, yeah, that's really great, but how many sources of interference may come in there and, shielding, pipe shielding, concrete walls, these sorts of things. What are you inadvertently putting in between the access point and your users? So that's another thing to consider. Let me jump down to this third bullet point. Oftentimes, wireless access points have some options. You can put a stronger antenna on, which obviously is going to boost the signal strength above what it originally would be. I mentioned using Network Shell on a Windows 7 client to scan and see what WLANs are available and which wireless channels being used. You want to make sure to not overburden the channels. The client should be able to auto-detect what channel the access point is running, so long as you have, as I've said about 100 times so far, the SSID. What are some techniques for administering and automating wireless in a Windows domain environment? Chief among those, of course, is group policy, and in our upcoming demo we're going to log on to a Windows Server 2008 R2 domain controller, and I'm going to show you those policies specifically. This is going to give us centralized control and the ability to centralize distribution of connection profiles for our wireless client. We also have Windows Connect Now, or WCN. This isn't so much of a business thing. You see this more often in residential or perhaps SOHO environments. WCN's been around for a few years now, and it's an umbrella term that comprises at least a couple different schemes or technologies. Maybe we can call them sub-technologies. The main aspect of Windows Connect Now is, as long as you purchase a wireless access point that was designed to conform to the Windows Connect Now API, then it makes it much easier to connect your, say, Windows 7 box up to that wireless access point, or also another Microsoft device like, say, an Xbox 360. In this screenshot we see down below, we see we've initiated a setup a network request from within Windows 7, and instead of having to go through creating the profile manually from scratch and having to know what a network name is, what encryption type we're using, all of that, which a lot of that terminology very obviously is far beyond the reach of a typical home user, you can just, in this case, for instance, type the 8-digit PIN from the router label. This is a router that supports Connect Now, obviously, and the rest is pretty much automated for the user. So Connect Now, in a nutshell, is a way to hide a lot of the complexity of setting up a wireless access point and establishing a client connection to it. Hides that, abstracts all that stuff, and makes the process pretty easy. Another aspect of Windows Connect Now that's kind of cool is this notion of USB profile backup. This screenshot brings that method to light. I showed you the Manage Wireless Networks dialog and control panel in Windows 7. And one thing you can do from the properties of your connection is, and this is an administrative option, you notice the UAC shield, I'm sure, copy this network profile to a USB flash drive. So what happens is you click this link, as long as you're an administrator or can properly elevate, and Windows will copy all of that profile information into an executable installer on your flash drive. The idea then is that if a guest comes over and needs to access your wireless network, instead of having to somehow generate that super long WPA passphrase and do all that rigmarole, you can simply run the installer from the USB key, restore the profile information onto that second computer, and voila, that second computer's up on your WLAN. Again, take-home message of USB profile backup. It's a way to abstract some of the complexities of establishing a client-side wireless connection and make it more accessible to the common man, to the common woman. In our demonstration, as previously stated, we're going to take a look at wireless-related group policy options in Windows Server 2008 R2. We are on DC Nugget 2. This is a Windows Server 2008 R2 domain controller for the NuggetLab2.com domain. And what you're seeing right now is the Group Policy Management console. You can open this through administrative tools, or my personal favorite way to go is to open a run prompt and type gpmc.msc. And I haven't been creating new GPOs for these examples I've been showing, and I'm still continuing that trend. I'm simply editing the default domain policy, group policy. It's all the same anyway, right? Same policies. And we've navigated under Computer Configuration, Policies, Windows Settings, Security Settings, and then you'll notice that we have Wireless Network IEEE 802.11 policies, as well as Wired Network policies. Now, the Wired Network policies deal primarily with that IEEE 802.1x protocol, and essentially that protocol spec provides what's called port-based security, such that somebody could, let's say an outside contractor, were to plug his or her laptop using an Ethernet cable into one of your drops, they wouldn't be able to get any network access unless and until they authenticated. It's a really nice way to do business. I also want to draw your attention to this collection of group policies, Network Access Protection, or NAP. This is how Microsoft implements Radius. So remember how I mentioned for WPA2 Enterprise, you'll need a Radius server and extensible authentication protocol, EAP, digital certificates, all that kind of stuff. NAP is the way you do that if you want to use Windows Server 2008 for a Radius client and or a Radius server. Also, finally, I know that we've talked about digital certificates a lot in this course thus far. This is where we also can distribute digital certificates. You'll notice in the public key policies node, we have encrypting file system, and you'll remember when we talked about EFS, let me temporarily turn off the console tree, I mentioned that in Windows Server 2003 and 2008 Active Directory domains, the domain administrator is the default recovery agent for the domain. This is where you're actually seeing proof of that, where the administrator recovery certificate is being made available in default group policy for encrypting file system. Alright, so enough para information. The wireless network IEEE 802.11 policies is blank by default. This is just one I was working on earlier. I'll delete it by right-clicking and selecting delete from the shortcut menu. By default, like I said, there's nothing there. We can right-click the node and notice we have two options for creating a wireless network group policy. We have an old school Windows XP policy and what I'll choose now, create a new wireless network policy for Windows Vista and later releases. I think you're going to like this. This is really cool. I'll call this Corp WLAN. This is the friendly policy name, and you can also add a friendly description for that connection, which users can see. Tells us at the top of the dialog that settings defined in this policy will apply to all wireless interfaces on client machines. Once again, remember that in a domain environment, you as a domain administrator own that computer. That is to say, all network interfaces, wired and wireless, will be associated with the domain Windows firewall profile, and you can customize exactly what's happening in terms of profiles by this policy. By default, we do want to use the Windows WLAN auto config service, and we'll want to make sure that users can't turn that off. You can control that as well in group policy. And basically, it's just a question of plug-in and chug-in. Notice that you can import .xml-based profiles if you've created them and exported them. You notice the button export is grayed out. You'll see that in just a minute. This makes it easy to share these profiles. I'm going to click add. Notice you can choose between infrastructure and ad hoc. These are the two main ways that you do wireless networking. Ad hoc is a peer-to-peer strategy. In my experience, we don't use that in business. It's just not scalable. Infrastructure is where we use wireless access points and wireless network controllers. So we'll choose infrastructure, and I'll call this profile Corp WLAN, one word, and I'll also just assume in the sake of this example that the name of the SID is Corp WLAN. I'll add that in. Connect automatically when this network is in range. Connect to a more preferred network if available. I'll untick that. Connect even if the network or the access point's not broadcasting. The security page is where we can abstract some of the protocol stuff from our users. Are we using, say, open? That's not advised except for maybe guest access. WPA Personal, WPA Enterprise, WPA2 Personal, WPA2 Enterprise. You notice that WEP's not even in this list. Or you can do open authentication with 802.1x, which actually is an authentication method. As I said, it's port-based, provides a lot of good security. I'm just going to choose WPA2 Personal here, and then you can choose either TKIP or AES, depending upon what you want to do there. If you choose AES, there's an advanced option. I'll actually choose TKIP here. Click OK. And once you've done that now, we have the profile show up. If we create more than one profile, we can jog their preference order with these arrows. If we click Edit, this brings us back. Here's the Export button if we want to export the profile as an XML file. Now, network permissions. What this allows us to do is essentially create exceptions to the preferred WLAN list that we've created on the general page. As a matter of fact, the text here says on the Network Permissions tab, wireless networks configured as preferred networks do not need to be added in the permission list. You'll notice that Corp WLAN is in there. We can't remove it from here. We have to come over to the general page. And of course, the permission is allow because we want to allow our users access access to that WLAN. Now, if you click Add, you can type in SSIDs that are not in the general list. You'd specify whether it's infrastructure or ad hoc, and then allow or deny. Like I said, this is most useful to specifically block SSIDs. For instance, you might have another business that's next door to yours that has some really powerful WLAN stuff going on, and they're broadcasting their SSID into your campus, and you want to do what you can to limit the possibility of one of your users associating with their network. You can add their SSID with an explicit deny, and they won't be able to do that. You can also make other restrictions, like disabling ad hoc in general. That's, like I said, not a good idea to give users the ability to create their own mini WLANs. You can allow user to view denied networks. I'm going to lift that restriction. The less users know about in this regard, the better. Allow everyone to create the all-user profiles. Only use group policy profiles for allowed networks. This is a pretty strict option where you fully want to control what networks are allowed while the user's computer is connected to the domain. There you have it, just a general overview to establishing a wireless network policy out of the box in Windows Server 2008. I hope you found this demo helpful. Managing wireless connection issues review. In this nugget, we looked first at client-side wireless configuration in Windows 7. I hope, especially those of you who, as I said at the beginning of this nugget, are going from Windows XP client-side setup to Windows 7, are much better grounded now than you were prior to watching this nugget. I am quite sure you'll agree with me that wireless configuration in 7 is much more straightforward than it was, say, in Windows XP. We spent some time looking at the mechanics of an 802.11 connection, including discussing, say, the different protocols, BGN. We talked about data encryption and authentication, SSID, etc. We looked at the methods for creating wireless profiles in Windows 7. You know that those are manual, USB profile backup, or we can use group policy. That actually ties us into our final bullet point, where I actually showed you those group policy settings in Windows Server 2008. I hope that this has been informative for you, and I'd like to thank you for viewing.